everyone, and welcome to TLDR Week 8. This week we're going to be talking about cryptography, public keys, digital signatures, and authentication. The first thing that we have to look at is what is encryption? So encryption is when we take a plain text message and use an algorithm to turn it into ciphertext. Decryption is when we go the other way. We take the ciphertext and use an algorithm to turn it back into plain text. Now, encryption and decryption is actually one of the fundamental building blocks of information security today. Encrypting and decrypting messages is how we are able to keep all of our information secure, from a customer database all the way to websites, so that when we are going to a website, say for our bank, we're able to make sure that other people aren't able to see what we're doing or snoop on us as we are doing our banking. There's two main types of encryption: symmetric and asymmetric. Symmetric key encryption means that we use the same key to encrypt and decrypt the message. Asymmetric encryption means that we actually use a public key and a private key. The private key is something that only you know. The public key is something that you would be willing to share with others. To be able to have asymmetric encryption, such as RSA encryption, work properly, you have to have a public and a private key, versus symmetric encryption, you actually have to share the key with somebody else. That's how you're able to encrypt and decrypt your messages. Now, both of these symmetric and asymmetric encryption options are different from hash functions in that one-way hash functions take the information, put it through the function, give us characters back out. But remember, it's a one-way, so there's no way to go from the characters that we've gotten back to the original message. Now, kind of going back in time a little bit, encryption is actually something that has been around for a very, very long time. This actually goes back to the, early Romans, Julius Caesar, people like that. So this has been around for a really long time. What ends up happening with encryption is the theory of encryption and protecting messages is something that, as a people, as a culture, everyone around the world has needed this, so that if we have, for example, a battle plan, well, we don't want the enemy to be able to know what our battle plan is. So we have to have a way of being able to send our message without unwanted people reading it. Now, one of the basic ones that's sort of a early version of encryption, not the more complex RSA type encryptions that we use for the internet today, is something called a substitution cipher. The way a substitution cipher works is you take the alphabet, so the regular English American alphabet, A to Z, and then you mix up the letters in some way, and you're going to do a substitution. So wherever you see an A in the original message, you would instead put a Q. Whenever you see a B in the original message, you would put a W. And that's actually a substitution cipher. So if you know what has been substituted, you can go from the ciphertext back to the plain text. Substitution ciphers are also one of the easiest ones to crack. You can do something called frequency analysis, which basically relies on the fact that in the English language, we know that the most commonly used letter is E by quite a bit. So if we have a long enough message, if we see a letter that pops up the most frequently, we can make an educated guess that it's an E and then go from there. For example, how many words are frequently used that are 3 letters? It's probably going to be something like the, and, stuff like that. So that's one of the ways that we can do a very simplistic encryption. Now, this is what was used for a very, very long time, but when computers started becoming popular and people started working with them in the 50s, they actually started doing computer encryption. Now, this was originally started with the Enigma machines. If you want to see a little more about that, there was the movie from a couple years ago, The Imitation Game. And you can actually see how the Enigma machines were created and cracked. After that, they had what's called the Digital Encryption Standard, which was the first sort of widely used. Now, this one was kind of interesting because there was actually a call put out towards everybody in the security community to participate in creating this digital encryption standard. And it's actually led to some bad blood and disagreements with some of the older generations for this because of the way the entire thing was handled. Now, the DES, Digital Encryption Standard, was released in the late 70s and it was actually broken right before Y2K. After that, they came out with AES, the Advanced Encryption Standard, and this started getting used more frequently. Cryptanalysis is the practice of taking the encrypted message and figuring out what the actual message was supposed to be. Now, frequency analysis is popular for things like substitution ciphers or Viennese ciphers because we can do things like look at what the most commonly used letters are. We can make some logical guesses. We can figure out, well, what's the most commonly used word in the English language. The other ways that we can actually do some basic cryptanalysis is we can do things like if you can convince them to use your given text, like let's say you have a paragraph, if you know the paragraph and you can convince somebody to run that paragraph through the algorithm, then you can sort of work backwards to figure out what the algorithm is. It's kind of the equivalent of working backwards from the answer in a math problem. You can also do something where sometimes you only know the ciphertext. Now, if you only have the ciphertext, that can be a lot harder to work your way back, but still possible. Some people actually do this for puzzles and fun. You'll sometimes see this type of game done in newspapers and stuff. Now, in information security, rather than referring to people as person A or person B, what they actually started doing was giving them names. So person A is Alice, person B is Bob. The person that is trying to intercept the message between Alice and Bob, instead of being the eavesdropper, we're going to call her Eve. So if Alice and Bob are trying to send a message to each other, they have to find a way to be able to send the message without eavesdropping on them. So you have to have a way of being able to, if you're going to do symmetric key, share the key back and forth. If you're going to do public key, private key, then you don't have to worry about sharing the keys the same way. During the live stream lecture, I have another little demo that I'm going to do and talk about I do a little rescue the princess example, but this is sort of the fundamentals. Alice and Bob need to send messages and they have to find a way to do it so that Eve can't figure it out. In Blackboard, there is also another write-up if a written explanation works better for you on public key, private key encryption. Now, whenever we have data, we have to make sure that we are encrypting our stored data. We never want to leave plain text data sort of sitting out. So if we have, say, backups or data in the cloud or data on our phones, we want to make sure that we're doing a proper encryption. There's actually quite a few different encryption algorithms. One of the current more popular ones is called Blowfish, but there's quite a few different encryption algorithms. Basically, the thing that you want to remember here is when you're thinking about encryption, don't try to do a roll your own encryption. Make sure that if you are going to be using an encryption algorithm, it's one that's sort of got a good reputation for a lot of people to use, such as something like Blowfish. You aren't going to want to use an encryption where they are, for example, be unwilling to share how it's put together or it's relied on a secret. That usually doesn't go really great. Normally I would do an in-class activity on encryption, but we're actually going to be skipping that. If you would like to play with Veracrypt, you are more than welcome to, but you don't have to. When you are talking about encrypting communications, You actually need to think about how you can send information to somebody else in a protected way. Now, if you're talking about seeing somebody in person, it's a lot easier to be able to tell them a secret. However, if you are never seeing somebody in person and you are only communicating with them through the computer, you have to figure out how you're going to be able to send them information and get information back. Blockchain is one of the buzzwords that's been going around for a little bit, and this is included in encryption because this is actually secure by design. The way blockchain ends up working is you have a whole bunch of people that are going to participate, and everybody is given sort of a simple math problem. Whoever solves the math problem first sort of wins that block, and then there's a new math problem that's given. When you have the different blocks, it is quite literally a growing list of records. You can kind of think about it like linked Excel sheets or something. You might have also heard of blockchain in terms of things like Bitcoin or Ethereum, if you're interested in more information about that. Now, one of the big issues that we end up having with encryption is actually a legal issue. One of the disagreements that's been happening between the government in the United States as well as other places and people in the world is who should have encryption, who should use encryption, and who should be able to bypass other people's. What I mean is, if we have, let's say, for example, a cell phone with emails, and this is the personal cell phone with personal messages, should it be possible that somebody else is able to read those messages? Does that answer change if we're talking about somebody who's set a bomb or they've shot up a school? Should we have a way of being able to access people's private messages? Now, one of the arguments that's been happening is a lot of governments have said, yes, we should have a golden key, and the golden key should allow us to be able to access anyone's message at any time for security purposes. Now, the problem with this is in practice, a golden key is literally a backdoor into the system. And if you have a backdoor into the system or a fundamental flaw in the encryption algorithm, there is nothing to say that somebody else can't find that flaw. So it's actually not possible to have a golden key that you can give to somebody but never have it be misused. So the current debate is sort of, is the misuse worth setting this up? Is the backdoor to the algorithm risk worth having the backdoor? There's also been some disagreement about key disclosure. Should you be able to force somebody to give up the key to their private messages? There's also some current restrictions on where cryptography can actually be exported. And there's also been some disagreements about where cryptography is allowed. Now, this is actually kind of interesting because you wouldn't really think about it as why wouldn't people want to use cryptography, but there are actually some places in the world that forbid well done cryptography and well done encryption. For the lab for this week, you are going to practice some password cracking. If you have any questions or problems, please let me know. Thank you.